Hello guys, this is Paul McWhorter from TopTechBoy.com with lesson number 59 in our legendary, our improved series of Arduino tutorials. What we are going to do today is we are going to give you the solution to the homework assignment that we gave you in lesson 58, where we're going to go in and build a portable distance sensor based on the HC-SR04 Ultrasonic Sensor. This really builds on the work that we did in lesson number 55. Remember, in lesson 55 we got the thing working where if it's plugged in you can measure distance and then get the result back to the serial monitor. Well, what we're going to do today is we're going to take that where we left off in lesson 55 and we're going to turn it into a portable unit that we can walk around with. Now, in order to do that, like if you look at where we ended up here in lesson if you look at where we ended up in lesson 55, let me see if I can find that graphic. It is right here. This is where we ended up. We had the ultrasonic sensor and then we had it hooked to the Arduino Nano. I used the Nano. You guys might have used an Uno. But in this build, what we are going to need to do is we're going to need to go beyond that, and we need to have a way to power the Arduino without being connected to the computer, and then we need a display. So we're going to have to add things to it. So I'm going to need you to pour yourself an extra large cup of ice cold coffee. And I'm going to need you to get your equipment put together. Now, everything that we have been doing in this series of lessons has been based on our eLego kit, the Super Starter Kit. If you don't have one, the link is down below. It's got a lot of the wires, breadboards, and components that you need. 35 bucks for a boatload of components and an Arduino. All right, but as I have been talking to you, as we're going to these more complicated builds, there's a few more things that I'm going to suggest that you get. I think that you need to get one of these larger breadboards linked down in the description to Amazon. And then to get a neat build, you need to use these straight jumper wires that are pre-cut that just slide right in so you don't end up with this rat's nest. You guys know that I'm not trying to just sell you a bunch of junk, but if you're going to continue with this, you need to have a nice set of equipment on your workbench. And so besides the eLego kit, I am recommending this breadboard. I'm recommending these jumper wires. And then I am recommending that to make cleaner builds, you really need to have a good Arduino Nano. And I've got a link to one of the official ones down below. And if you made it this far in this series of lessons, you deserve it. You really need to get you a Nano. Now, if you just can't do it at all, you can do the project with the Uno, but you are going to have to run jumpers from the Uno to the breadboard, and that's going to make it a little harder to walk around with. Also on this project, you are going to need some way to power all this portably, and I think the easiest way to do it at this point is to get a USB power bank, one of the things that's used like to charge a cell phone, and then you can connect that directly to the USB on the Arduino, and then the Arduino can power everything. So that is what I am suggesting. So the first thing that I like to do in a project like this is first thing I like to do is unplug the Arduino, because when I'm doing a build like this, I don't want to do it while the Arduino is plugged in, because if I hook something up wrong or I make a mistake, there's a chance you can short something out and either damage a component or you can cause a problem with the Arduino. And so for this build, I think you could possibly make this fit. I like to just start by just kind of laying things out in possible fashion. So if I move the Arduino all the way over, and then I put the display here, and then I put the sensor here, the ultrasonic sensor, it just might fit. It just might fit. Now I'm trying to think through this. I'm really wanting to go through this because I feel like go to this larger board because I feel like there's some things that might surprise me. I would still need to put this, but I think I could get that like that. All right, now what I am thinking is I really, really, really need these pins on the LCD. I really need those on the side where the digital pins are. And you know, darn it, it looks like that could really happen in this configuration. So that's lined up right, and then I could come on across to the sensor, that everything would be lined up here. But man, that's going to be, I would want to move the Arduino as far down here as I could, straddling. Let's see if maybe this other view would work a little better. I know I've got this view here somewhere. There it is. Okay. You see, I would want to straddle that center trench so that I'm not shorting the Arduino pins together. But you see, I would want it as far possible down, so I would leave myself as much build space up here as possible. And then down here, probably all I would be doing, I think, would be needing to maybe do a ground down here, but not even sure I would need to do that. So that, you know, guys, I think I'm going to try to build it on this single board. So I'm going to go ahead and plug the nano in. Okay, and now I'm going to take these other wires out and keep them handy. Let's see here. Which view do you guys like better? That's actually showing up pretty good for right now. So we'll go back and forth between the overhead and this webcam view. The webcam gives you a really good view, but the problem is it's got kind of a wonky autofocus sometimes. So now I would also want to give myself as much room as possible with the LCD display. And I wouldn't want to put it down here because I don't want to go around a corner with all those digital wires. And so I would probably put it like this. Okay. Now I've got a nice straight run from the digital pins on the Arduino to all these pins that need to be hooked up. Let's see here. I'm going to go ahead and leave that jumper in that connects the row 2 power rail to the bottom row power rail. All right. And now the sensor, I really want to put as far forward as possible, because as I put it down lower, like if I put it here, I really don't want any of those build wires to have the possibility of getting in front of the sensor. And so I could put the sensor like here, something like that. I usually, if I can avoid it, I don't like things hanging over the edge of the board, even though the pins fit. I don't like to do that because it's too easy to bump something and knock it off. And so I could put it even like right here. Okay, and that would be pretty good. But in fact, I think what I'm going to do is I'm going to put it forward. And you know what I could do? I could actually do something like that. All right. Now I'm having to think of what the problem would be if I had it that far forward. The problem is that I have to connect to on the ultrasonic sensor to VCC and ground, and if I go all the way up, I'm not leaving space to jump directly over. So what if I did this, moving it back? Okay, now I have got room to do the VCC and ground connections, but it is going to be tricky. No, I think, you know what, I think, and then I would still have room to run over the trigger and echo pins. The trigger and echo pins, I would still have a place to run. This is getting a little bit scary, my friends. This is getting a little bit scary. All right, now what else do I need to do? I've got to get this potentiometer, and what if I put the potentiometer like this? Okay, if I put the potentiometer like this, I've got to leave room to connect to VCC and ground on the two outside legs, and so I don't want to go all the way up into the top. But if I'm in the top you see if I go second row from the top, the problem is I don't have, it doesn't fit. You know, it's wanting to then plug into the trench. You see, it doesn't fit like that. So unfortunately, what I'm going to have to do with this is I'm going to have to straddle the trench. I'm going to have to straddle the trench. And then that's going to leave me one kind of annoying connection. And that connection is going to be from the center tap. And that is in there very poorly. Okay, that is now in there square. Okay, I kind of had it in there not in a good way. Now the only problem that I really have is this center tap of the potentiometer is going to have to kind of go around a corner to get to where it needs to go on the LCD. I guess I could look and see, am I really in that last row? Yeah, I'm really in the last row. So I'm going to kind of have a little bit of a challenge and not really a very neat run to go from here over to here. I'll tell you, my instincts are telling me that I should go to the bigger breadboard at this point. But with a little luck, this just might work, and I might have like one connection that's kind of a little bit of a challenge running from here over to the LCD. Okay, so let's start hooking this thing up. And what I'm going to go to a crazy view, which is probably going to make you mad. But I think that you can follow me if we go to this view. All right. And I do here probably need to get even further out of your way. So what you can see is you can see the overhead view way over here in the corner. Okay. And then the view from the webcam right above me. And then you can see the two bond outs that we're going to be working to. Now, if you cannot see these bond outs clearly, go to the website, www.toptechboy.com. We are on lesson number 59, and I've got these schematics there. And so if you're having trouble reading them off of your screen here, go to the website, get them, print them out, and then you can have them big in front of you. But I will try to use this view so you can sort of see it all at the same time. I also will be trying, and I know it's annoying, but I will be trying to keep this camera focused. This webcam does a really good job, but sometimes it loses its focus, and I'll try to use that little piece of paper to keep it in focus. Okay, did you guys follow? I think this might be something that we can do. So the first thing that I need to do is I need to look at this, and I think that just about everything that I'm going to be doing is on this top side. And so I need to go in and just kind of start, believe it or not, I think I'm going to start with the potentiometer. And if I look at the diagram with the LCD, you know with the potentiometer that you need the two outside legs, one connected to ground and the other connected to the 5 volts. And it doesn't really matter which one is which. It's just that center tap is the important one. And so let's start here by, oh, look at that. I just broke that little wire. Or the little wire broke. I didn't break it, but it broke. So I want to get VCC to the outside leg of the potentiometer. Now I need, I'm sorry, that's the ground. The ground of the right side of the potentiometer went to ground. The left side of the potentiometer is going to go to, this is not good. You know what happened? The way I have it here, this leg of the potentiometer is not lined up with the hole. And so I just really like to be super neat and super careful with these things. And so I'm going to move it over a little bit so that everything will align, and work on those pins a little bit. And then right like that. Okay, now I will put the right leg of the potentiometer, I'm going to take to ground. Right leg of the potentiometer is going to go to ground. And I've told you guys this before, sometimes these things just do not want to plug in, but you don't want to force them. What you want to do is you want to kind of jiggle them until they just slide in, because if you try to force them, it will break the pin. Okay, right leg of the potentiometer is into the ground. So what that would leave is now the left leg needs to go to 5 volts. Okay, the left leg is going to go to 5 volts. And again, what I'm trying to do here is get it to slide in smoothly, which I just did there. Okay, so you see how that is so nice and neat. Now, I'm going to have to go ahead and deal with this center leg of the potentiometer. And if I look at that, and then I'm going to turn it this way so I'm oriented kind of the same way where the pins are on the bottom as you see over on the corner of the screen. I want to get the pins on the LCD pointing down, so I'm oriented the same as the schematic. And oriented that way, what I can see is that the center leg of the potentiometer goes to the 3rd pin from the right. So the center leg of the potentiometer needs to go all the way over here to the 3rd pin from the right. And this, my friend, is going to be ugly. So it's going to go 1, 2, 3. Okay, I think that's labeled V0. 1, 2, 3, 3rd from the right. Man, I'm checking this so carefully. 3rd from the right is going to go to the center leg of the potentiometer. So I'm going to come in, and then I'm going to try to kind of tuck this under there because I really, really, really want this wire out of the way. The good news is this is going to be kind of the most problematic connection. So I'm going to try to just see if I can angle it and then come over here to the center leg of the potentiometer. Because you see, what I'm doing is I'm thinking ahead, and I don't want that connection to then get in the way of everything else that I'm going to have to build. So you see, we go from the 1, 2, 3rd leg from the right when the pins are on the bottom, and then come over here to the center leg of the potentiometer. And that actually came out better than what I had hoped. I'd been anticipating this to be a problem, but you see it actually kind of is out of the way and looks pretty neat. All right, so let me go back over here to this view. The potentiometer is hooked up. Now I want to just kind of go in and take care of some of my VCCs, my voltages, and my rails, my ground rails. And so on the Arduino, remember, when you're building, you want all your grounds hooked together, and so you wouldn't want to just come in and plug into the Arduino and not have it actually grounded to all the other grounds. So I'm going to establish this bottom ground rail, which is the bottom row here, and I'm going to do that by coming to the ground pin on the Arduino and tying it to that ground rail. And in effect, I'm kind of establishing that as the ground rail now. Like I say, I don't think that I'm going to have to create a ground rail on the top, because that should take care of that. I don't think there's anything else in particular here that is going to need to be done. And so now I want to probably go ahead and hook up the ultrasonic sensor, because it's pretty easy. And I'm going to need some more small wires. So I will need a VCC, a voltage, a 5 volt, and I'm going to need a ground on the ultrasonic sensor. So I'm going to come into, if you look oriented like this, the VCC is on my left. So I will come in, and it's going to be kind of tricky. And you know what? I might just pull this out a little bit so that I can get my finger in there. And that's going to be to the second row from the bottom. So I'm going to just kind of have to pull this out, I think, because I will not be able to put that in with it in. So I'll put that like that. So then that takes care of the VCC. All right, now I need the ground, and so I will come in and go from that VCC pin down to the ground. And again, I do not want to bend this wire. I'm off by 1. So now I know where it is, so I'm going to take that out, and I'm going to just kind of not force it. It's not wanting to go down in there, and so I just want to kind of jiggle it. And guys, it's just so tempting to just try to, try to force it, but you don't want to do that, because once you get these wires where they're not straight, then you fight with them from now on. So I'm going to try to straighten that. You want them to come straight down. So let's skip 2. This should be it. That should be it. And okay, there, slipped right in. Okay, now if we come back with the sensor, okay, that looks pretty good. I do need to go back further if I can, like that. Okay, I think that will work. Now we've got to get the trigger, and we've got to get the echo. And if I look at that, let's see, the ultrasonic sensor wants the trigger to go to 12 and the echo go to 11. And if I look over here, it looks like 12 and 11 and 13. No, 12 and 11 are already taken. So I could take this to pin 13, which is not being used. And where is pin 13 on the nano? Am I going crazy? Am I going insane? Or does the nano not have a pin 13? I think the problem is pin 13 maybe, if I'm reading this right. Mine is a little blurry, and I'm afraid that pin 13 might be down here on that corner, which would not be good. So let me go back over to this view. And so I don't want to bring it down here. So then what are my options? Well, it looks like pins 2 through 6 are not used. And so 2 through 6, I could use pin 2, and I could use pin 3. So let's see if we have a wire that would be able to help me make that happen. And you can see that real quick here, a challenge that we're going to have is we are going to have a lot of stuff running through here. So we have to be as neat and careful as possible. So I'm going to start with the echo pin, and I want to bring the echo pin, and it does not quite long enough with this wire to get to pin 2, which is a problem. Okay, so I'm going to see if there's any way that I can get that, because it would sure be nice to have that connection. And that is D2, and there is no way it is going to work. So I'm going to have to go to something a little bit longer. And guys, if you're just bored with me, we'll just go do it on your own. But the reason I am stepping through this with you is so you can hear me talk out loud, because it can be a challenge. It can be a challenge to get these things to work. Now, at this point, another possibility would be for me to move this way or this way to get it to fit. And I think I am going to do that, because I don't want to bend the wires. The other thing is I could come this way and use that orange wire. Okay, let's see what the implications would be. And guys, if you see somebody that just hooks things up perfectly the first time, it's because they've already done it. You've got to think through this. So let's say I said that I was going to use D2. I'm going to kind of try to work up here high. I'm going to go D2 over to here, all right, and then similarly I'm going to go D3 because I needed 2 digital pins. I'm going to go D3 let's see, I'm going to start over. I'm going to start with D2 with a nice straight wire and take it as far as I can. So D2 will come here, and let's see if we can get that in there. Otherwise it's going to have to go like that. Okay, that is going to be the best that we can do. Okay, so then the next one will be D3. So in case you're wondering what I am trying to do, I'm trying to get it where the sensor can be hooked up with relatively straight wires and then still leave myself build room down here. Then what we also know is, if we look at the sensor, that when I have it like this, I need a ground on the left, and so the left pin would need to be a ground, which I took out that little wire and I lost it, so I'll go get another one. I need to stop losing these little wires because they are precious. So the left one on here needs to be ground. The left one on the sensor needs to be ground. So if I come down like this, now you kind of see why it's good to put your ground wires in first. And as much as I don't like to do this, okay, I'm going to do it like that. So now the left one is ground, and I need to make the right one 5 volts, like that. All right, so now let's look at this. The left is ground, which it's supposed to be. Then I have echo, and then I have trig, and then I have VCC. So that looks right. So if I plug this back in now, I think with a little luck that will be hooked up. Okay, what I don't like is that wire is kind of keeping me, I need to go one more back, I think, like that. Okay, so now I have this as far back as possible, and I think I've got this thing hooked up. And the only thing I don't like is this orange wire is running on top of this ground wire. I can't really move the ground wire, so I've just got to make sure that that stays securely plugged in. All right, this is kind of interesting, and I think I might have this hooked up now. So I'm going to go ahead and plug in. And you see, this is such a complicated build. Before I do anything else, I want to see if we have that ultrasonic sensor working. So I'm going to plug the Arduino in. Good news is I kind of got the happy little sound, so I don't think that I shorted anything out. And so then let's go over here to a code view, like this. Okay, and now this I believe this was where we left off in lesson number 55. So you can go to lesson 55 and you can get this code. Okay, you can go to lesson 55 and you can get this code. Let's see, I want to make sure that I have a good view here. Give me just a second to sort through all these views. This is probably a pretty reasonable code view. Okay, now what changed though? My echo and my trigger pin changed. So here the trigger pin is now pin 2. So I've got to come to my code. And my trigger pin is pin 2. Now my echo pin is, I think these wires crossed. I've got to be very, very careful. The trigger pin is that one. You know what we didn't do? We should have written it down as we put it in. This one is the trigger pin, and the trigger pin is in fact D2, and then the echo pin is pin 3. All right. Man, this is so tedious, but if you try to do this just by using a bunch of loopy jumper wires, you're going to have some problems. Okay, and then we come in again. This is pretty straightforward. We set up the ping, we send it, we've done all the math already. And so I think we are ready to download this. And what we want to see is if our basic distance sensor works. I need you to hold your breath. Oh, denied. What does it not like? It might not like having a serial monitor already open. So let's see. Try it again. Oh. Ooh. Hey, looks like it downloaded, but now what we need to do is we need to look and see if we can see that serial monitor. And okay, and I seem to be getting a very spurious result here. Can I make it where you can see the serial monitor? Okay, give me just a second to edit this shot so that you can see it. This is one of the very annoying things. It sometimes doesn't like to have 2 Arduino windows, so it loses track of which is which. Okay, I believe that you can see that now. And so what you see is that I'm measuring 0, so something is not working. So let's look. And let's come back over here and let's look and see what it is. VCC is definitely to 5 volts. But nothing is creating VCC. So you see, the problem is there is nothing that is turning the sensor on because I don't have this power rail, row 2. I didn't establish it. And so I've got to find the 5 volts on the Arduino, and as luck would have it, the 5 volts is on the opposite side, so I can't drop a rail right up there. But the good news is I've jumpered the bottom plus to the positive plus, so if I hook this one up here, I should be good to go. So let's see what happens here. I'm going to come and I will make sure it's got to go to the bottom row. So I will come in here and I will go there to 5 volts, and then I will come in and it slips right in. Okay, boom, all of a sudden I am getting measurements. Okay, so the problem was I was thinking maybe we confused that echo and trigger, right, because we were getting a little confused there, but in trying to see what was connected to what. But now, boom, look at this. Okay, so this is looking pretty good. Okay, so the sensor is working, and that's a huge, huge step. So now, and the reason that's giving you strange numbers is because there's not a target. If we put a target there, it works. All right, now what do we have to do? We have to hook up the LCD, and this is something that we have to be super, super duper uber careful with, because the LCD has a lot of connections and it's easy to get confused. So I'm going to go to a view that will show you like this. We've got the ultrasonic sensor hooked up, and now we've got to look over in the corner on how to get the LCD hooked up. And I think what you need to do is you need to get some view. You need to get where you can see that schematic. If you can call it up from the website, that would be great, but you need to get somewhere where you can see that big. I'm looking for, like here, you see, you can see it big, but the problem is if I use this view, if I use this shot, then you're not going to be able to see my hands, and you're not going to be able to see the build. And so therefore you need to go to the website and either print it out, but you got to have it some way that it is in front of you big. This would be another possibility, but I think I would rather you see the two angles on the build. Okay, so let's look, and we're looking, and now what I need to do is, if you look at that schematic, the pins are on the bottom, and so I need to move it like this so that I am oriented pins on the bottom, just like if you look in the corner on the schematic, the pins on the LCD are on the bottom, and that I think we really, really, really need to do. And so now we need to begin to hook things up. We've got the one connection. I'm going to unplug this from power as well as we're doing this. We've got the one connection already from the potentiometer to the third pin from the right. Now the rightmost pin is ground, and then the second to the right is power. And so we ought to go ahead and take care of that, I would think. So I'm going to get a couple of these small little bitty jumpers and get that taken care of. Power the thing up to begin with. Okay, on the right is ground. Okay, on the right is ground. So I need to kind of move these out of the way. And then, unfortunately, I'm not lined up perfectly. I've got one of these that's has a blank spot right there, but I can go over one and get it in there, and that goes right in. Okay. Now, the second pin from the right on the LCD wants to go to 5 volts. Okay. So I've got 1, 2, 3. I've got the first 3 pins hooked up. The fourth pin, let's see, and then the fifth pin. The fifth pin also, The 5th pin also is going to be a ground. So 1, 2, 3, 4, 5th pin on the LCD, the 5th pin from the right, also wants to be a ground. And I can kind of, okay, so I'm going to check that. And man, this is where you have to check over and over. I look at the schematic. 1, 2, 3, 4, 5 is a ground. And then I come here. 1, 2, 3, 4. 1, 2, 3, 4, 5 goes to ground. I believe that's right. Now we need to go back and look at 4. 1, 2, 3, 4 from the right. 4 from the right goes to pin 7. So here is where things get dicey. I go 1, 2, 3, 4 from the right wants to go to pin 7. And I am just way, way, way too long for that. So our faint hope is that one of these shorter wires would work. So I go 1, 2, 3, 4, 5. Is going to go to still too long. You can see why it really, really, really helps to have a nice set of these wires that come in a nice different array of sizes. Let's try this one. So we're going to come. The other thing you can do, which really we're probably at the point, is to buy a roll of this wire and get some diagonal cutters so that you can make them exactly the size you need. So let's go again. 1, 2, 3, 4. The 4th one from the right goes to pin 7. So I'm going to go 1, 2, 3, 4th one from the right. Doesn't quite go to pin 7. And pretty soon we are getting to the point that we will need to just bend a wire around to make it work. 1, 2, 3, 4 wants to go to pin 7. And then it's going to go, let me start at the other end maybe. And so if I go all the way to the other end, we're going to have some fun. And so the leftmost pin is going to want to be a ground. And so if I'm going to make that leftmost pin a ground, what am I going to need to do is take this sensor out for a minute so that I have some room to work. So leftmost pin on the LCD is going to go to ground. So leftmost pin on the LCD will go to ground. Okay, and now second pin from the left wants to go to power, wants to go to 5 volts. So second pin goes to 5 volts. And I'm resisting the temptation of jamming this thing down in there. Okay, so I have the left pin hooked up. I've got the second pin from the left hooked up, and now the third pin from the left wants to go to 12. The third pin from the left wants to go to pin 12. It needs to be longer. Third pin from the left needs to be longer. Trying to kind of get different sizes out here to work with, so I'm probably going to have to use a yellow one. So third pin from the left 1, 1, 2, 3. Third pin from the left wants to go all the way to pin 12, which I am going to have to accomplish by looping back. Okay, and then, okay, do you see how I looped back there? Let me give you a focus here. Okay, you see how I had to kind of loop back, but then I'm also trying to keep this wire nice and out of the way. So now I've got on the left one, the second one from the left, and the third one from the left hooked up. 1, 2, 3. The fourth one from the left is going to want to go to 11. And so I think I'm just going to have to continue to make these little looped back wires like this. And it is going to get kind of ugly, but I'm going to try to get it in there like that. And then again, I will need to make a loop back. But I want to do the loops where I'm keeping this wire as straight as possible. So that is going to go to 11. Okay, and now I want to take that slack out like that. Can you see how that's still staying relatively neat? And so that was the 1, 2, 3, 4 from the left, 1, 2, 3, 4 from the left went to pin 11. Okay, and so we're going to have the same type of thing. The nice thing is they kind of begin to go in order, and so if you can try to keep things in order like that, there's a lot of different ways this LCD can be hooked up, but when you run them across in the same order that the pins are, it kind of helps a little bit. So now I'm going to try to come back up to that right by the LCD and see if I can get that in. Okay, and now that one, which is the 1, 2, 3, 4, 5th from the left, 1, 2, 3, 4, 5th from the left, wants to go to pin 10 now. So I will need to. I'm going to see if one of these other ones would fit in at this point, because the things are coming towards each other. And yes, they will. And in fact, I think this is pin 10. Now I'm going to go maybe I will have to use this. Okay, now that is going to want to come back to pin 10. Okay, so that's pin 10. And now I have 1, 2, 3. Now the next one is going to go to pin 9. So 1, 2, 3, 4, 5, 6 from the left wants to go to pin 9. And so 1, 2, 3, 4, 5. And I am off by 1 on that. I need to put that one back in. And I'm just going to have to come down here like that. And then that wanted to go to pin 10. So you see, you've got to keep checking your work, because it's a lot easier to correct something right after you put it in than when you have more wires on top of it, because as this thing continues to build, it becomes harder and harder to debug. So that was pin 10. Now what I know is 1, 2, 3, 4, 5, 6 from the left needs to go to pin 9. So 6 from the left needs to go to pin 9. And then let's see where 6 from the left is. 1, 2, 3, 4, 5, 6 from the left, which I can scoot right in there. And I will come back and check this. And I'm just going to look and see if by some chance a shorter wire would work. Not even close. So this one too is going to have to loop back. And this will be pin 9. So pin 9. And then draw it in there tight and kind of loop it back like that. This is really getting to be a mess here, and I don't like that, but since I don't have diagonal cutters, I really don't have a good solution. So now we need to skip the next 4, and then we need to go to pin 8. So I need to skip. I'm going to start working from the right again. Okay, I'm going to start working from the right again. So the next thing I need to do is from the right, 1, 2, 3, 4. Okay, 1, 2, 3, 4 from the right needs to go to pin 7. So pin 7. Pin 7 is going to go to 1, 2, 3, 4 from the right. Needs to go to pin 7. And I just really am always hoping I'll find a wire that will do this. 1, 2, 3, 4. Is that going to make it? Denied. Okay, so 1, 2, 3, 4 is going to go to pin 7. So I will have to make one of my famous little loops there, and then bring it up here like this. Okay, so that looks pretty good. This is turning out to be a little bit of a nightmare. And so I've gone 7, and now I have the ground, and now I need to I have another ground here. Okay, so there's one more ground that we need to put in. Okay, so let's look at this. We have 1, 2, 3, 4, 5th over from the right should be a ground. 1, 2, 3, 1, 2, 3, 4, 5th over is a ground. And then we go to, maybe I am not missing a ground. Okay, we have hooked up pin 7, and pin 7 goes 1, 2, 3, 4 from the right. 1, 2, 3, 4 from the right is pin 7. 4 from the right is pin 7. And then the next one is the ground. And then the next one needs to go to pin 8. So the next one okay, I am just going to check this, man, because I got to be so careful. First one on the right goes to ground. Next one on the right goes to 5 volts. Third one goes to the potentiometer. Fourth one, 1, 2, 3, 4, goes to pin 7. Fifth one is a ground, and that's right. And now the next one is going to pin 8. Next one goes to pin 8. Need a little longer wire. So the next one goes to pin 8. I will need to bend it. Okay. Now I skip, let me just see, I just want to check. So after pin 8, I should skip 1, 2, 3, 4, and then I should be making connections again. So I skip 1, 2, 3, 4, and then I have a connection which goes to pin 9. Okay, that looks like it's hooked up right now. That was TD-us, right? TD-us, but I think I've got it all hooked up now. I'm going to go ahead and be brave, and I'm going to plug it in, and let's see what happens. What I want to hear is the happy little noise and maybe some sign of life. Got the happy little noise, and I've got some signs of life on the LCD. The screen came on, so that's pretty good. Guys, before we go in and program, up the printing the distance, what I really want to do is I want to just do a hello world on the LCD. What do we know at this point? What we know is that we are getting good distance measurements, right? We know that we are getting good distance measurements. I think so. Is this working? Okay. What did I forget to do? Why am I not getting good distance measurements? Because I didn't plug this back in. Now we know this is all in the right place, but we had to kind of take it off in order to, give our little fingers room to put these wires in. And so we need to plug this back in most carefully, and I think I need to go further back like that. Okay, now what do I not like about this? Those wires have kind of got this thing now. So I want to plug it in where the wires are not keeping this from plugging in all the way. Okay, and that is going to be like that. Okay, that is pretty good. And now are we getting any type of measurement? Let's see. Hit the reset button. This thing still is not coming to life. Okay, so this was working earlier, but now is not. The good news is I did not see any smoke coming out of any of this. Okay, let's see if we download this program again, if we can get something to come to life. It doesn't like that when the serial monitor is on. I'm trying to download the program again. Let's see if I can give you a view here. All right, I got it downloaded now. Let's come up here, see if the sensor, okay, at least I'm getting some readings off the sensor and they are starting to look good. Okay, so we got the sensor plugged back in, and now if I come over here to this view, again, I'm sorry, but when I kill the serial monitor, it's like the Arduino is kind of fighting with my broadcast software. So I've got to fix this where you can see it again. So give me just a second here to configure this so that you are actually seeing the serial monitor. Okay, this will fix it. Okay, so do you see now that I am getting measurements that are looking good? All right, so that is good news. That is good news. So now what we need to do is we need to see if we can get a hello world up here. So I need to take you back to a good code view. And let's see, I wonder if that one is not live. Okay, let me see. Let me just check one thing here. Sorry. Okay. There was a good view here. I believe I should be able to get the view here. With a little luck, I have it. And then if I make that smaller, I want you to be able to see what my hands are doing. And I want you to see the serial monitor and the code view all at the same time, which I think maybe we've accomplished with this view. All right, so that is looking good. And so now let's come back over here and let's see if we can get a code view going. All right, so what do we want to do? We want to make our LCD say hello world. So we're going to have to set up the LCD now. In software. And let me remind you of where we did this kind of thing in our lessons. So if you haven't done this before, you can go back to our LCD. Which was connecting and using the LCD Arduino tutorial 48. You can see it on this channel, on this playlist, or you can go to toptechboy.com and find Arduino tutorial 48. And I show you the coding on this. But let's go ahead, you can follow along with me here. We are going to first have to set up our library. So I think Liquid Crystal is one of the libraries that is already on there. If there's any confusion, go back and look at that lesson. It shows you include. All right, we want liquid crystal.h. What are we doing? We are loading the liquid crystal library. Remember, on library loads, you don't put a semicolon. Now, how did we hook this up? We hooked RS to pin 7. RS on the LCD went to pin 7. Int EN went to pin 8. Int D4 went to pin 9. I'll tell you guys, this LCD project is the project that separates the men from the boys or the women from the little girls, because it's the project that if a student isn't careful, they just can't do it. And this is kind of the make or break things for students in the engineering program. But the good thing is it teaches you to be careful and methodical, and even if you don't become an engineer, you become a nurse, well, you've learned to think clearly and be careful and precise. Good characteristics for people in the medical profession. So no matter what you're planning on doing, I think it's good to learn to work carefully, as I forget to put equals 10 on that. All right, so D5 is equal to 10. Int D6 we had hooked up to pin 11. Okay, int D7 we hooked to pin 12. All right, that looks good. Now we have to create the liquid crystal objects. So we're going to use the library liquid crystal. Turns the happy little orange color. We're going to call it our LCD. That's our object. And then the order is RS EN D4 D5 D6 D7. Okay. Now you could have just come in here and put 7, 8, 9, 10, 11, 12, and that would have worked, but it's better to use variables, because if we have a problem, we can go in and check things. Then, okay, so we created the object. Then down in our void setup, we need to begin our LCD. So we're going to do an LCD.begin, and then this is 16 columns by 2 rows, the LCD that we're using. And so that starts that. That looks good. Now in the void loop, okay, we make our measurement, and do our calculations, and we can still print it to the serial monitor, that's okay. But what we need to do is we need to LCD dot set cursor, happy little orange color, and we're going to set the color, the cursor to column 0, row 0, and then we're going to do a LCD dot print, and we're going to say hello world, and then we are going to do a delay so that you can see it, and then we are going to do a LCD dot clear. You always want to clear it so if you get something you don't end up with garbage from the last print. And now we just got to make sure delay time should be longer here, like maybe 100, let's say. Okay, let's download this and see what happens. LCD clear, I think, needs to have the open close parentheses. Hold your breath. Downloaded, okay, downloaded, and are we getting anything here? Boom, we are getting a hello world. We will turn it around. Boom, look at that. Hello world, Did you see that? We hooked it up right. Did yours work? I hope yours worked as well. If you were as careful as I was, it probably would. Because, man, this is a booger bear to try to find an error when you've got all these wires. So let's look here. Let me go back to this view. And if you look at those wires there, man, if we had had a problem at this point, trying to troubleshoot that is very hard. And I told you my intuition was telling me that I really needed to go to a bigger board, but we did get it fit on here. Ooh, microphone crash. Okay, we did get it fit on there, so that's pretty good. Now that blinking business, it's a little blinking. Let's work on our delay here a little bit. Maybe we need to have a little bit longer delay. Let's put it at like 500 because it's a little bit blinky there. I'm sorry, you guys are not seeing that. You need this view here. Okay, so let's come over here. Let's make this 500. That's half a second. And maybe I would get a little less jitter in that. Okay, that looks a lot better. So I think now I can bring you back to this view. Okay, now why is it reading 18 inches? Because I don't have a target in front of it. Okay, and I want to make sure all my connections are super good. Okay, look at that. So what is the super cool thing here? The super cool thing here is, I want to get that just right. And I'm checking all of my connections. And that one. Okay, so that looks good. I want to see what happened if I take that LCD clear out. I've got several delays in here, so I just want to see if I take the LCD clear out. I need to give you back your code view. I took the LCD clear out, and now I'm going to download it. Okay, that looks pretty good there. For some reason, I was getting it kind of blinky a while ago, and I didn't like how it was blinking, and it made me think maybe I had a bad connection. But okay, now we don't want to print Hello World. Let's see if I can get a better view. Will this one work here? Okay, yeah, I think that one will work. So now let's see if we can really print something. And so let's see if I could print here instead of Hello World. What if I said target distance? Do you think that will fit? I bet it doesn't, but we can correct it if it doesn't. Target distance. Now I'm going to do an lcd.print. And then in that earlier lesson, what was the variable? Distance to target as such. Okay, but where do I want to put that? I can't put that on that same row. I better do an lcd.set cursor, and I still want to be where? I want to be row, I want to be column 0. Again, it starts with column, which is kind of backwards for a math teacher. And then I want it to be row 1, like that. And then I want to print distance to target. All right. And then what I will do up here is I will actually give you a target. And then let's see if we can download this and see what happens. Yes, it downloaded. Hey, look at this. Huh? Do you see this? Do you see this? Distance to target. Target distance 1.7 inches, 2 inches. Look at that. Boom, shakalaka. Yeah, boom. Did you see that? Look at that. Let's give you the more dramatic view. Is this the more dramatic view? Oh, look at that. I'll put a target there so it can see it. Oh, look at that. Come on, focus. You're messing me up here, Mr. Webcam. This webcam gives you a pretty nice view, but then it's got a real wonky autofocus, which, there. Okay. Now look at that. So let's put a target here. And then, oh my, beautiful. Look at how neat this build is. Now, we just ran into some difficulty here. The solution is to get a roll of wire. We need to probably do that and get some diagonal cutters and start making the things exactly the right size. All right, what's the one thing that we should probably do? If we come back over here to where you can see the code, will this work? That is not very nice. Let's come back over here to our good old faithful here. We probably want to put units, and so then let's do lcd.print, and then let's do space inches. Okay, and then do that. And then let's see what happens. Now here we might have a problem if we don't do an LCD clear, so let's go ahead and download this. That is going to download. We might have to go back and put an LCD clear in it. So let's look at this and see what happens. Okay. That looks good. But let's say if I go to something really big and then come back. Do you see how that messed it up? Because now the inches scoots over and you have that trailing S on it, as I feared. So let's see if we go back and after the delay, if we put an lcd.clear, this was giving it a little bit of a blinky business before. So, okay, I'm sorry you didn't see that. What I did was right here, after the delay, I put in the LCD clear. So let's come back over here to this view. And what I'm hoping now is I'm hoping that we don't get, okay, I am not getting a lot of problems. problems there. Okay, now if you just let it go, that blink is because it's looking for a pulse that it never got back. And so there's a delay after the clear. And so that... All right, man. Look at that. Okay, are we done? We are not done. What have we not done? We have not gone portable. And so what you need is you need like this USB power supply, this USB power bank. And so what I'm going to do, I'm going to unplug from the computer. Okay, I'm going to unplug from the computer. And so do you see now that we are completely untethered, that this thing isn't connected to anything? So I think I can come back up here. And what I can do is I can get the power bank and then I can plug it in like this. And then, look at that. We are completely mobile. We are completely mobile. So then, let's look. I guess I do need to put it back over here. All right, and that little bit of blink is because it's looking for a ping that it's not getting, and it's after the clear, and so that is pretty straightforward. All right, so hopefully you believe we are completely mobile at this point. And then if I put a target here, we're getting nice glitch-free operation. If it goes to a long distance and then it comes back, you're still getting a good reading. Oh man, and look at this. Is this not a nice looking portable system? Now if this was in the real world, I would find a much shorter cord to power this thing with, and so still the power is something that you got to think about a little bit. But man, that is really slick. Okay, did anybody do this along with me? Did anybody play along at home? You guys give me a comment down below and let me know. Did anybody actually do this? First of all, was anybody able to do it on their own? Was anybody able to do it on their own? And if you were, did you do it the way I did it? Did you end up with something like this? Can you see, man, if you try to do this with the Uno and you were running all of these wires with these loopy wires, you probably would have really run into something that if you got it to work, it's probably very glitchy. And so if you guys haven't done it already, get yourself a nano and get you some of these straight jumper wires. I bent up so many of these jumper wires, I'm going to have to like buy me another kit because I've really messed up a lot of those wires. And so I am just super duper happy with this thing. I'm super duper happy with the way it came out. Would love to hear your comments down below. Did you get it working on your own? Did you get it working after you did it with me? What were your problems? Did you do it the way I did? Did you do it some other way? Did you just fold up like a cheap lawn chair and go back to playing silly video games? Or did you run from the room crying like a little child? Or did you actually get this done? You see, when you start getting to this level of a project, it's not that it's just that hard, but you just have to be so careful and so precise, and you have to focus, particularly as we were running those wires on the LCD. So I would love to hear your comments down below. All right, we are going to, let's see, what else do we have coming up here? We did the homework. We made a portable distance sensor. I need to give you your homework for next week. All right, your homework for next week is keep this thing put together, but do you see this thing is like making measurements when I don't want it to, and then it gives erroneous measurements. And so what I want is I want this thing to sit here, and I want it to have a push button, and I want you to only make a measurement when you push the button. Okay, I only want you to make a measurement when you push the button. So you push the button, it runs off and makes a measurement. And that way it's not just sitting there and kind of getting wonky things going on. So the assignment for the next lesson, and I'll go over it in lesson 60, the assignment is to go away and add a push button switch where you push the button and it makes a measurement. Okay, Paul McWhorter from TopTechBoy.com, enjoying coffee after a successful build. I will talk to you guys later.